What if a city-sized visitor slipped into our solar system and it was not a natural wanderer at all? What if the brightest new interstellar object refused to behave like any comet we know? What if the numbers point one way but the picture in front of us points somewhere stranger? Tonight we open that door together and we keep it open long enough to feel the draft of something bigger than our familiar sky. 2 weeks ago the James Webb Space Telescope took a long careful look at an object called 3I Atlas. It is only the third confirmed interstellar traveler ever seen in our neighborhood. On paper it should have been simple. Point our best infrared eyes at it. Read the light. Learn the recipe. Stamp it comet or stamp it rock and move on. That is not what happened. The data came back with a signature that bends our expectations. The glow around this thing carries a huge cloud of carbon dioxide. The water that should be roaring off a sun-warmed comet is faint. The dust that should stretch into a long tail is not there the way we would expect. It shines hard yet hides its crumbs. It invites and it withholds. Could it be that we are looking at a special class of natural body? Yes, that is possible. Space loves to surprise patient observers. But the first impression is powerful. There is a mismatch between what our textbooks teach and what our best telescope sees. And that mismatch sets a hook deep. We are not just watching another icy traveler. We are watching an argument unfold between common sense and raw measurement. That is where real mysteries begin. Here is why the opening seconds matter. In the first moments of any great story the question takes shape. We do not bury the lead. We hold it up to the light. With 3I Atlas the lead is simple to say and hard to shake. A massive carbon dioxide halo. A brightness that seems to come from the surface more than from dust. A missing tail where a giant brushstroke should be. And a size estimate that pushes into small city territory if the surface is dark like many outer system objects. If the surface is very bright the body could be smaller. Either way the object does not settle down inside a neat label. It wriggles. It keeps asking for more attention. Could it be that the heat from the sun is skipping across a reflective shell so the water ice stays locked in while carbon dioxide escapes through cracks? Some researchers lean that way. Others point out that we have seen rare comets with more carbon dioxide than usual, but even those carry obvious tails and a different look. The safe answer would be to shrug and say unusual but natural. The honest answer is that unusual here means out on the edge of what we have documented. That is where curiosity does its best work. We stand at that edge now. Think of a locked door in an old house. You can feel cooler air seeping under the wood. You can smell the faint trace of something you cannot name. You wait for the sound of footsteps on the other side. That is 3I Atlas today. We have a key ring full of normal explanations. We try each key in turn. They do not turn cleanly. The knob resists. The lock groans. We look for a spare key under the mat. There is none. So we kneel down and we peer through the narrow gap and we describe what we see. A round haze. A bright core. A light that seems to come straight off the skin of the object. A wind of carbon dioxide that spreads far and thin. Not a thick sandstorm of dust. More like a cool breath that carries no grit. There is also the weight of recent memory on our shoulders. A few years back we met the first interstellar visitor we could track across the sky. The press named it Oumuamua. It rolled end over end. It changed speed in a way that did not match a clean slingshot around the sun. It shed no visible plume yet it drifted off course ever so slightly. Many argued for exotic ices lofting off unseen. Some suggested solar pressure on a thin sheet. Others said our data was too sparse for big claims. What stayed with us was the feeling that we had watched a magic trick from the wrong angle. We caught the effect but missed the move. That feeling returns with Atlas. 2 odd guests in 1 young century. It makes you lean forward. So what exactly are we looking at here? That is the heart of the episode and the spine of our journey. We ask it now and we will keep asking it as the clues stack up. Are we seeing the cold chemistry of a body born in a different kind of nursery where carbon dioxide sits near the skin and water hides deeper? Are we seeing a giant fractured crust that lets one gas fly free and holds the rest? Are we seeing a mirror bright shell that keeps the heat out and starves the normal comet engine? Or are we seeing something built with a purpose that does not belong to geology? A shell. A shroud. A disguise. We will not claim what we do not know. We will show what we can see and we will trace the shape of the unknown around it. There is a reason to stay with this story. When a new world refuses to match our categories, it changes us. It forces better questions. It invites new tools. It makes our maps more honest. In the middle of that work there is also room for wonder. Wonder is not the enemy of science. Wonder is the spark that keeps us awake as the data loads. Wonder is the warmth in the room where the graphs glow on a cold screen. Tonight we let wonder sit beside evidence. We let caution sit beside imagination. We let the old rules meet the fresh exception. We will move fast because the first 30 seconds are the make or break window for attention. You deserve a clean deal. Here it is. A huge carbon dioxide haze. A faint water signal. A brightness that points to a reflective skin. A missing tail. A size that could be frightening if the surface is dark and still impressive if the surface is bright. A path through our system that we will study in detail later, which raises eyebrows for reasons we will explain. These are the cards on the table. No tricks. No jargon. Only the raw pieces that demand assembly. Imagine the stakes if the boldest path is real. A natural body is beautiful. A crafted body is history. We do not leap there without care. We put each plank down and we test it. But we also do not fence off that direction out of fear of being wrong. Some scientists believe rare chemistry can do the job. Others are not so sure. Both sides deserve a fair hearing. Our role is to walk the line with you and keep the tension alive without draining it of truth. If the bold path is true, it changes everything we thought we knew about visitors between the stars. If it is not true, the careful process we use will still teach us about the building of worlds in cold places. There is a simple promise to you as we start this series. We will not pad the time with filler. We will not hide behind dense terms. We will not hammer you with claims dressed up as facts. We will show the puzzle. We will test the pieces. We will leave room for your own take at every pause. The mystery belongs to all of us. Space does not care about egos. It rewards patience and clean thinking. It also rewards the guts to ask the question that sounds wild at first yet refuses to die when tested. We end this opening where a good hook should end. Right on the lip of the question that keeps you from clicking away. We have a visitor that glows with carbon dioxide and keeps its water shy. We have a light that seems to come off the skin of the thing. We have a tail that is not doing what tails do. We have a size that might be massive. We have a memory of another visitor that bent the rules and left without clearing its name. We have a choice about how brave we want to be with our next step. So what exactly are we looking at here? Stay with that line as the music fades down and the first diagram fades up. In the next part we set the stage with names, times, distances and instruments. We slow down for a breath. Then we push forward again. While you wait for that next beat, tell me this in the comments. If this object turns out to be purely natural, does that result satisfy you? If it turns out to be anything else, do you want us to try to speak to it? Your answers shape where we go next and which leads we chase first. Imagine if one of those answers becomes the line we quote the day the truth finally steps into the light. We begin by laying the ground under our feet. A telescope does not argue. It gathers light and draws a line on a graph. The James Webb Space Telescope is our finest tool for that kind of work. It listens in the infrared where cold objects speak clearly. 2 weeks before this story reached you, Webb stared at a visitor named 3I Atlas. The eye marks interstellar. This is only the third time in human history we have tracked a traveler from another star passing through our neighborhood long enough to take its measure. That alone gives the moment weight. NASA paired Webb with another infrared mission called SphereX to cross-check what the light was saying. Both instruments are built to decode chemistry from far away. They turn faint heat into a fingerprint. In theory, the job sounds basic. Read the fingerprint. Compare it to the library. If it smells like a comet, then say comet. If it smells like a rock, then say asteroid. Reality had other plans. Before we chase the weird, we set the scene. Interstellar objects are not bound to the sun. They swing in from deep space and leave again on open paths. The first one we confirmed had a Hawaiian name that means first scout. It came and went fast. It gave us a taste of how little we know about what roams between the stars. The second one was easier. It wore a classic snowball style with a tail and a coma and a spectrum we could relate to. That second visitor felt like a relief. The universe looked normal again. Then came Atlas. The moment Webb looked closely, a pattern broke. Here is what a normal comet does near the sun. The surface warms. Ices turn to gas. Dust lifts off like ash. Sunlight and solar wind push the dust into a graceful tail that points away from the sun. The glow we see is a mix of sunlight bouncing off dust and the faint signature of gas. Water is the star of that show because water ice sits near the surface in many comets. Carbon dioxide is there too, and often deeper. The ratio between these gases usually falls inside a familiar range. Ground truth from decades of comet work anchors those expectations. Now we pose the central question that anchors the whole episode. So what exactly are we looking at here? Is Atlas a rare but natural kind of comet forged in a cold place with an odd mix of ice near its skin? Or are we staring at something else that only pretends to be a comet from a distance? The answer lives in the details. And those details start in the data that took longer than expected to reach the public. The delay could have been simple logistics. It could also have been the time needed to test a result that felt off. Either way, the first official look did not settle nerves. It stirred them. Webb reports a massive cloud of carbon dioxide around the object. Think of a thin shell of gas that extends a vast distance from the core. At the same time, water vapor is faint. It is not zero, but it is low compared to what a sun-warmed comet tends to exhale at that distance. Carbon monoxide is also modest. The shape of the glow tells another story. Instead of a long dramatic tail that stretches away from the sun, we see a more compact envelope. High-resolution images from other observatories agree. The bright signal appears to come straight off the surface of the body more than from a fog of dust. Put those facts together and the object refuses to sit inside the comet box without a fight. Why would carbon dioxide run free while water hangs back? One mainstream idea says the surface could be unusually reflective. A bright shell would bounce sunlight rather than soak it in. That would keep the shallow layer cold and could reduce how deeply heat can dig. If heat barely enters, buried water stays quiet while pockets of carbon dioxide near the skin find weak points to vent. Another idea points to crust. A hard layered outer shell could cap most ices while a handful of cracks act like narrow vents for a specific gas. Both ideas keep the object inside the natural world. They deserve a fair shake. But context matters. We do have a rare precedent for a carbon dioxide heavy comet. That older case still showed a classic tail. Atlas does not. We do see signs of water ice in absorption, suggesting that water is present but not acting like the engine. That is odd at this distance from the sun. We also face the question of brightness. If the glow really is dominated by sunlight from the surface rather than dust, then the core might be large if the surface is dark. If the surface is mirror bright, the core could be smaller. Either way, the numbers do not land where our intuition would place them first. The size estimates span from big to very big. The mass could be far beyond the first two interstellar objects combined. That mismatch between brightness and behavior is one of the knots we will pick at in later parts. Let us slow the pace for a breath and talk about how Webb knows any of this. Infrared light acts like a gentle lie detector. Molecules vibrate in patterns that leave small dips and peaks in a spectrum. When Webb splits the light from Atlas, it sees the signature of carbon dioxide carved into the graph. It also sees the weaker marks of water and carbon monoxide. The instrument records how much of each pattern is present and how the flow changes with direction. That is how we know the plume is denser on the sun-facing side and how we estimate the rate at which the object is losing mass. None of those steps are exotic. They are standard practice for a machine built to study exoplanet air and dusty nurseries around newborn stars. The method is solid. The result is what stings. Now we circle back to the central question. If the chemistry is odd and the shape of the glow is odd and the brightness points to the surface more than the dust, what does that tell us about the nature of the core? We do not jump to labels. We line up the options. 1. A natural comet with an unusual composition near its skin that vents carbon dioxide while holding back most water. 2. A natural body with a reflective outer layer or a hard crust that reshapes how heat moves and how gas escapes. 3. A rubble-covered rock that carries patches of volatile ices in a pattern we have not modeled well yet. 4. An object with elements that are not purely natural in origin. We keep that last door in view without walking through it. Not yet. This series will test each door one by one. There is a human rhythm to the way we meet a new puzzle. First we try the most boring fix. Then we try the rare but still natural fix. If those fail, we start to wonder out loud. Wonder can be risky for reputations but useful for progress. The important trick is to keep the pulse of the story without cheating the truth. What we know today is simple to list. Atlas carries a huge carbon dioxide haze. Atlas shows weak water vapor compared to the carbon dioxide. Atlas lacks a classic long dust tail. Atlas looks bright in a way that implicates the surface. Atlas might be larger than anything we had reason to expect from the interstellar stock we have seen so far. None of that forces a non-natural conclusion. All of it justifies a long look. One more piece of context belongs here. The path of an interstellar object tells us about its past. Odds are most of these bodies are scraps from faraway planetary cradles. A disk of rock and ice around another star throws debris out during the rough years of planet building. Most pieces drift in the dark between suns forever. A rare few wander close to a star like ours and light up. If Atlas was thrown out from a system with different temperature zones or different chemistry, its skin could be odd in a way that feels surprising to us. That helps us keep our humility. Our sample size is tiny. Our library is thin. We end this part the way a good setup should end, with pressure still building. We have named the instruments. We have set the normal expectations. We have shown where Atlas bends those lines. We have carved the guiding question into the wood so it stays visible as we move. So what exactly are we looking at here? In the next part we stop generalizing and we put down the first unusual detail like a card on green felt. The first card has the carbon dioxide watermark that refuses to fade. It is the kind of card that makes the table go quiet for a second. Before you click ahead, take a beat and weigh in. If you had to pick a door today, which one do you try first? Rare natural chemistry. Strange surface physics. Misread brightness. Or a design with a purpose. Your pick will not settle the science, but it will sharpen the hunt. Curiosity thrives on many minds pulling on the same knot. We place the first card on the table and hold it there long enough for the edges to sink in. The glow around Atlas is dominated by carbon dioxide. Not water vapor roaring off sun-warmed ice. Not a snowstorm of dust peeling away from a fragile crust. Carbon dioxide, thin but vast, spread like a pale shell around the body. A comet near the sun is supposed to carry water at center stage. Water should sing the loudest. This one whispers. Carbon dioxide hums instead. It sets the baseline and everything else follows its rhythm. Think about the reach of that haze. The cloud does not stop a short hop from the core. It stretches outward an extraordinary distance, far enough that the scale feels unreal when you say it out loud. Imagine a bubble so wide you could fit planets inside the circle. The density thins with distance, yet the pattern holds. It is not a narrow streamer pulled into a tail. It is a broad envelope. The sun-facing side looks a little thicker, as if sunlight is pulling the cork on a specific bottle while most of the bar stays shut. The shape fights the picture we keep in our heads when we say the word comet. Now we talk about the mix. Instruments that listen in the infrared can tell gases apart by the way they sip heat. Carbon dioxide leaves a distinct notch in the spectrum. Water does too. When the numbers are lined up, the ratio between carbon dioxide and water looks lopsided. The carbon dioxide line rises strong. The water line sits low. Some teams estimate a ratio near 8:1 in favor of carbon dioxide at that distance from the sun. That is far beyond the usual playbook for a comet warming up. It is not unheard of for carbon dioxide to be high, but this level and this pattern of behavior make people sit forward. There is also the silence where a grand gesture should be. A classic comet paints a long calligraphy stroke across the sky. Dust lifted by the gas gets pushed back by sunlight and by the solar wind. It makes a tail so clear a child can point to it. With Atlas the supposed brush is thin or missing. High-resolution images do not show a bold tail stretching away. The light we see seems to be shining from the skin itself more than from a bright fog of dust. That is why size estimates start to balloon if you assume a dark surface. A bright mirror-like skin would shrink the body, yet that scenario raises its own questions about how nature would polish such a shell. It should not be possible for a warmed comet to hide its water this well while breathing out so much carbon dioxide. And yet here it is on our screens. The familiar order is inverted. The main actor has left the stage and the understudy is delivering every line. The audience knows the story is the same play, but the energy feels wrong. That kind of wrong is not a failure. It is a clue. Nature is telling us we left something out, or that we assumed a rule that only applies to our small local sample of icy bodies. Let us look at the force of that breath in human terms for a moment. The estimated carbon dioxide loss hovers around 100 kilograms per second. Picture a city where every person exhales, and you could match that number with millions of lungs. A single object in deep space is pouring out gas at a rate that mirrors a packed island of people on Earth. At first that sounds like a party trick for scale. Then you remember that every kilogram of gas leaving carries momentum. Over time it can push on the core. If water were the gas, we would expect the spin and the path to show certain quirks. Carbon dioxide alone makes the push different. We will return to that when we stack more cards later. How does a surface pull off this selective venting? One straightforward idea says the skin is bright and hard. If sunlight bounces away rather than soaking in, the top layer stays cold. The shallow pockets of carbon dioxide near the surface can heat enough to escape through micro cracks, while deeper water ice remains stuck in the shade. Another idea says the crust has grown into a layered armor over eons in the dark between stars. If carbon dioxide was trapped in pockets right under that armor, slight warming could pop those pockets while water stays trapped by a stronger seal. Both ideas are natural. Both stretch familiar processes into a new pattern. Both avoid grand claims while respecting the weird. There is also the matter of the cloud shape. A spherically symmetric envelope suggests countless tiny sources rather than one big jet. Some have suggested that little grains of carbon dioxide ice might break free and then vaporize as they drift, feeding the large bubble without throwing much dust. That could help explain the haze without painting a long tail. Yet even if grains do this work, the brightness still seems to be anchored to the surface more than the cloud. The nucleus is doing more of the shining than a dusty coma would. That refuses to sit easy with the grain story unless the grains are fewer than the brightness suggests. At this point you can feel the two voices of the story speaking over each other. The careful voice says rare chemistry and crust physics can stack into a natural solution. It points to one known comet with a weird carbon dioxide to water balance and waves at that as a cousin. The adventurous voice says this stack of oddities belongs in a different file. It wonders aloud whether we are watching a shell designed to keep heat out and manage a specific kind of venting. It does not claim. It wonders. That is allowed. That is also dangerous if it runs ahead of the facts. So we guide both voices down the same hallway and make them share the same light. Here is the clean summary of what this first anomaly means. The strongest gas signal around Atlas belongs to carbon dioxide. Water is present but quiet. The cloud is more of a bubble than a tail. The brightness implicates the surface more than a dust fog. The mix of those facts breaks the simple comet picture. The first anomaly is not just one odd number. It is a package that points in the same direction. The package says the engine that runs a normal sun-warmed comet is not running here in the usual way. If true, that alone would make Atlas a new kind of case study. If this is only the first card, we have to ask what waits underneath. We end this section with a small but sharp rise in tension. A mini climax is not an explosion. It is a click in your head when the weight of the evidence leans past neutral. This is that click. The carbon dioxide halo is not a footnote. It is the headline. It sets off a chain of consequences that reach into size estimates, surface behavior, and the missing tail. If a single gas can rewrite that much, then either we misread the whole picture of what comets can be or we are looking at a skin made to behave this way. Some scientists lean hard on the first path. Others are not so sure. You do not have to pick a camp yet. You only have to admit the click. Before we move on, imagine standing near a locked metal door that exhales a thin cool mist but never leaks the hot steam you expect. The metal groans now and then. The handle stays cold. The smell is unfamiliar. You do not kick the door open. You put your ear to it. You mark the pattern. You listen for the next sound. That is where we are with Atlas. The next sound arrives in the following section when we let the mainstream explanations have the floor. They will work hard. They deserve the chance. Then we see if their key turns. We hand the microphone to the calm voice in the room. The mainstream view starts with the simplest fix and works outward. It says you do not need an exotic engine to get an odd plume. You might only need an unusual skin and a tricky dance between light and heat. Imagine a shell that reflects more sunlight than a typical dark comet. If bright grains and a tight crust bounce the energy away, the surface stays cooler than we expect. Carbon dioxide buried very near that cool skin can still find narrow paths to escape when the sun nudges it. Water locked a little deeper never warms enough to roar. The result looks like what we see. A pale carbon dioxide bubble and a quiet water voice. This view also points at the way heat moves through layered material. Many comets build crusts as they travel. Sunlight boils away the softest stuff and leaves behind a tougher rind. Over time that rind can turn into armor. If carbon dioxide lies in pockets right under that armor, any slight crack becomes a vent. The gas slips out evenly in all directions and builds a bubble. Water trapped below thicker layers stays home. No fat jets. No showy dust storm. Just a steady breath that makes a wide envelope. The instrument sees the carbon dioxide clearly because the lines it leaves in the spectrum are strong. It sees water too, but muted by the lid above it. There is another idea ready to help the mainstream case. It says maybe we are not seeing the whole dust show because dust is scarce or the grain sizes are wrong for an easy tail. If the object sheds mostly large grains, they do not get pushed into a bright streamer the way tiny grains do. They fall back or stay close. If it sheds little shards of carbon dioxide ice instead of rocky dust, those shards can vaporize as they drift and feed the big bubble without painting a long ribbon across the sky. The coma grows without the classic tail. A viewer expects a brushstroke and gets a halo. The mind rebels, but the physics can handle it. The cautious voice also brings up geometry and timing. A faint narrow tail can hide if it lines up with our line of sight. Think of a thin plume pointing straight away from us. From our seat it would be almost invisible against the glare of the coma. A small angle change could reveal it later. Astronomers have been fooled by geometry before. The sky is cruel that way. One snapshot in time does not always tell the whole story. Now we add the point about brightness and size that keeps people up at night. If the surface itself is doing most of the shining, and if that surface is dark like many outer system objects, then the body could be very large to reflect this much light. The mainstream answer says wait for more measurements before you lock that in. Perhaps the surface is brighter than assumed. Perhaps there is a thin layer of reflective frost or fresh fractures that glint. A brighter surface means a smaller core for the same amount of light. The range collapses. The city shrinks. The alarm quiets. To keep the science honest, the mainstream side looks for cousins in the catalog. It points to a known comet that once carried an unusually strong carbon dioxide voice compared to water. That case still showed a tail, but it proves that nature can shuffle the deck in strange ways. It also reminds us that our sample of interstellar bodies is tiny. 3 visitors is not a library. 2 of those 3 have acted weird, but with numbers this small it is risky to shout pattern. We may just be meeting the loud ones first because quiet boring bodies are hard to find. Bias can trick eager minds. The cautious voice also asks if our instruments could be fooling us. Spectrometers are built to be reliable, but no tool is perfect. Calibration drifts. Background noise sneaks in. The shape of the coma can confuse models that were tuned on classic comets. Teams check and recheck because extraordinary claims demand cruel self-audits. That is healthy. It is not fear. It is the discipline that keeps discovery from tipping into fantasy. There is a clean way to picture this mainstream frame. Take the standard comet machine and turn the knob slightly off-center. Turn up reflectivity so the surface stays cool. Turn down the depth of heat penetration. Add a layered crust with micro vents near the skin. Set the dust knob to big grains or to fragile ice crumbs that vaporize before they can paint a tail. Let sunlight pull harder on carbon dioxide because it sits higher and needs less heat to escape. You now have a body that breathes differently under the same star. Odd, yes. Outside nature, no. The appeal of this frame is obvious. It conserves assumptions. It asks for no new actors. It keeps our world tidy and our pride intact. It honors the long history of harmless anomalies that folded back into the rule book once we had a better look. It also leaves room for surprise without leaving the laboratory. Many scientists live in this room by choice. They build careers on patient work that pulls the wild idea back to Earth using careful math and better data. We owe them our respect and our attention. But the mainstream story also has to carry the full weight of the facts, not just the ones that fit easily. That is where the tension returns. It must account for the missing grand tail and the surface-dominated brightness at the same time. It must explain why water stays shy while carbon dioxide blooms in a way we have rarely seen near this distance from the sun. It must handle size estimates that grow unwieldy unless the surface is a mirror compared to average. It must also fit whatever we learn about the path this object takes through our system. When one knob is turned, other gauges move. Every fix creates new questions unless all the needles settle together. This is not a fight. It is a stress test. We are not rooting against the natural explanation. We are asking it to climb the same hill the bold idea must climb. The good news is that data will keep coming in. Different instruments will look from different angles. Colors will get split in finer ways. The coma will evolve as the object moves. If the mainstream picture is right, the clues should start to harmonize. The halo shape should line up with vent physics. The brightness should drift in ways that match a reflective or crusty skin. Water might wake later if the sun bites deeper. History is full of cases where patients solved the riddle without invoking anything beyond geology and ice. Still, there is a reason your pulse quickens even while you nod along with the measured talk. The contrasts are stark. The first confirmed interstellar visitor bent rules. The second looked normal. The third swings back toward strange again. When rare turns into repeat, the human brain smells a trail. We are careful not to overfit a story onto a small set of points. Yet we also refuse to ignore the itch that says pay attention. That itch has served explorers well since the first map was drawn on a cave wall. We keep our promise on pacing. We pulled you in fast with the anomaly. We eased off to let the mainstream case breathe. Now we pick up speed again. There is another card to play, and it is heavier than the first. The shape of the coma is not the only odd feature of Atlas. There is the question of tail, size, and the eerie way brightness seems to come straight off the skin while crumbs are scarce. When we stack those details, the mainstream door creaks louder as it opens. It does not slam shut. It complains. Hold your own line as we move forward. Some scientists believe the natural frame will absorb these facts with time and better models. Others are not so sure. You do not have to choose a camp tonight. You only have to decide whether the careful fixes feel like a smooth path or like a patchwork that needs another stitch every page. In the next part we push into the second anomaly and raise the stakes. The room gets quieter when that card lands. Before you go on, tell me in plain words where your head sits right now. Does the reflective crust story feel strong to you? Does the layered armor with micro vents make you relax? Or do you feel the gap between brightness and behavior widening? Your read helps shape which measurements we highlight next and which alternative models we stress test in later parts. We turn the next card and feel the table steady and then tilt again. The second anomaly is not about chemistry. It is about shape and shine. A normal comet near the sun grows a long visible tail made of dust. Sunlight and solar wind push those tiny grains away from the core. The tail stands like a flag on a windy day. With Atlas the flag is missing or thin to the point of a whisper. High-resolution views show a glow that hugs the object. The light we catch seems to come off the surface more than from a bright fog. That single fact pulls a long chain behind it. If dust is not doing the heavy lifting, then whatever shines must be the skin itself. That pushes us toward size. Brightness is not a feeling. It is a number. The light you see depends on how big the object is and how reflective its surface is. A dark body must be larger to reflect the same amount of light. A bright body can be smaller. Many outer system objects are dark. They wear the stain of space on their skin. If Atlas has a dark skin and if most of the light is bouncing off that skin rather than off a cloud of dust, then the body could be huge. Some estimates put the size up near the range of a small city if you assume a common level of darkness. That image turns your stomach for a second. A city-sized body slipping through our system with a strange breath and a quiet tail does not feel routine. There is a way to shrink it. If the surface is very bright, even mirror bright in the extreme, you can keep the light output and cut the diameter down to something closer to a large mountain. A bright shell would do that math. But when you say mirror bright, you must ask what polishes a natural interstellar rock to that level and keeps it that way during a long cold crossing. That is not impossible in principle. Ice can be reflective. Fresh fractures can glint. Frost can shine. The question is whether that extreme is the right hill to defend. The mass question grows in the same soil. If the body is on the large side, then its mass could dwarf the earlier interstellar visitors by huge factors. The first traveler we met was small by most measures and light as a result. The second one felt more like a classic comet but still lived in a modest range. Atlas could be far heavier if the surface is dark. A heavy object carries more momentum. It is harder to push off course with soft outgassing. That matters when you try to explain any later changes in speed or path. It also matters when you think about how the coma forms and how long a thin skin could vent gas before it thins. The tail that will not show up keeps shouting. Comets make tails even when they do not try. You just need dust in the right size range and sunlight will do the rest. The absence of a clear tail suggests that Atlas is not throwing off many grains in that sweet spot. Maybe the crust is stronger than average so it sheds fewer crumbs. Maybe the grains are too big to float as a bright streamer. Maybe the grains are not rocky at all but tiny shards of carbon dioxide ice that evaporate before they can draw a clean line. Any of those could mute the tail. Yet all of those still have to pay the bill for the observed brightness if we keep the claim that the surface is doing most of the shining. There is a simple test we keep inside our heads as we lay these pieces out. Does each fix solve more than one problem or does it only patch a single hole while it opens another? A bright skin helps with size but strains belief if you push it too far. A strong crust helps with the lack of dust but also asks for a structure that survives a long interstellar drift and then wakes up in just the right way under our sun. Large grains cut down the tail but would often still produce some visible structure. Each piece can help. None feels like a silver key that turns the lock cleanly on the first try. Look at the geometry for a moment. If a thin tail were aimed almost straight at or away from us, it could hide in the glare. That trick of alignment has fooled us before. Yet the pattern of the glow in different wavelengths still favors a surface-driven shine. The angular spread of the coma looks more like a halo than a streamer. The sun-facing side is a little richer, as you would expect. The rest is nearly round rather than drawn back into a ribbon. Picture a frost that gleams across a hard shell rather than a cloud that blooms and trails. That picture is stubborn. When the surface is the main mirror, texture matters. A crust pitted with tiny reflective patches can boost albedo without turning the whole body into a perfect mirror. Fresh fractures can be bright. Icy veneers can form when gas vents and then refreezes in the cold shade. That would raise reflectivity above the drab baseline of many outer system rocks. The question is how high and how stable that reflectivity could be over days and weeks as the object moves. Future frames will help. If the brightness changes in step with rotation, that hints at patches. If it changes as the sun bites deeper, that hints at new frost formation or the loss of sheen. We should talk about the breath of carbon dioxide again because it ties into this second anomaly. If small grains of carbon dioxide ice are being released, they can feed the wide bubble as they vaporize. That process would create a coma without a heavy dust tail. It could also coat nearby surfaces with a thin bright layer if vapor recondenses on the shaded side. That would increase reflectivity in a natural cycle that depends on sunlight angle and local microweather. The halo would stay broad. The tail would stay shy. The surface would stay shiny. This story begins to sound tidy. But then the size creeps back in if the reflectivity does not reach the extreme needed to push the diameter down to a comfortable number. We add one more layer. If the bulk of the light is surface-based and if the object is large, then the gas we measure is being vented from a skin thin compared to the full body. You can strip a millimeter or two per year and still barely touch the core if the core spans many kilometers. That picture feels both plausible and haunting. It means the object can maintain a giant coma for a long pass without obvious erosion scars. It also means what lies under that skin can stay hidden behind the mask. A theater stage with a fresh coat of paint tells you very little about the load-bearing beams. At this point the second anomaly does its job. It raises the stakes beyond a weird gas ratio. It challenges our sense of scale and our sense of how comets show themselves. It asks us to entertain a city-sized traveler if the skin is dull, or a polished mask if the traveler is smaller. It invites us to wonder whether nature alone can keep this balance or whether some choices here look like engineering choices. We keep our stance. We do not claim more than the facts allow. We let the facts do what they are already doing. They push on the doors in our minds. This is the beat where a mini cliff lands. The glow hugs the core. The tail stays shy. The surface does the shining. The numbers for size lean large unless we accept a startling shine. If the body is truly that big and if it breathes the way we see now, then every other detail in this story will have to orbit those facts. In the next part we let the bold idea step into the light for a minute. We ask what this picture looks like if someone built the skin to act this way. We will not sell you that idea. We will test it. Curiosity deserves at least that much. Before you turn the page, tell me your gut read in plain words. If Atlas is dark and huge, do you feel calm that nature can make and launch such a beast often enough for us to meet one now? If Atlas is bright and smaller, do you feel good about a natural polish that perfect? Or do you feel the door to a design shell cracking open? Your words help us weigh which models to press hardest in the next round. We let the bold idea step into the light and we do not blink. What if the skin of Atlas is not only a surface but a system? What if the bright patches are not a weathered crust but panels or plates chosen for a purpose? What if the calm carbon dioxide breath is not only geology waking up but a managed exhaust that keeps heat under control and hides the usual comet fireworks? We do not claim this is true. We walk the path just far enough to see where it turns. Some scientists dismiss this road before the first bend. Others are not so sure, because a few pieces fall into place a little too neatly when you allow yourself to consider design. Start with the shine. A reflective shell keeps heat out. Engineers on Earth use thermal blankets on spacecraft for the same reason. A bright skin bounces sunlight rather than soaking it. The inside stays cool. If the builders wanted to keep water ice locked down, a reflective layer would help. They might even polish or refresh that layer using vapor that vents and then refreezes into a thin glittering frost. The result would look the way Atlas looks. A hard sheen on the outside. A quiet water voice despite sunlight. Carbon dioxide sits closer to the skin in many natural settings. It would be the first to slip out through micro joints or hairline seams. That breath would grow a wide bubble without painting a big dust tail. The sky would show a halo hugging the body. The tail would refuse to pose for pictures. Now talk about the breath as a tool. Spacecraft use cold gas thrusters for small pushes. It is a gentle way to steer. Imagine a giant body that uses controlled venting of carbon dioxide for thermal relief and for tiny coarse trims once near a star. You would not need big fireworks. You would only need steady valves buried under the skin. Open a cluster facing the sun and you dump heat while you add a whisper of push. Close them when the star falls behind you. The average viewer sees a symmetric cloud with a sun facing puff and no showy jets. The acceleration on the path would be small but measurable over time. If the body is large, even a modest exhaust could add up across weeks. You would expect the rotation to stay steady if the vents open in balanced pairs. That is the kind of control a builder would plan. The missing dust is also a feature in this story. A sealed exterior would not shed many crumbs. That protects the shell and protects the story the shell wants to tell. Less dust means less tail. Less tail means fewer clues. If any grains do escape, and if those grains are fragile bits of carbon dioxide ice that flash to gas quickly, they would feed the halo without leaving streaks. Observers would argue about whether the light was coming from the surface or the coma. In this scenario both do some work, but the design keeps the surface in charge of the shine and the coma in charge of the cover. Size becomes a different kind of question under the design lamp. If the shell is bright because someone wanted it bright, the body can be smaller and still glare like a giant. The range of possible diameters swings down from a small city toward a large mountain. A large mountain is still enormous by human scale, but it no longer feels impossible as a built structure if you think in terms of a hollowed asteroid. Our own engineers have written plans for turning carbonaceous rocks into habitats because stone and ice are the best shields against cosmic rays. A ship cut from an asteroid is not only science fiction. It is a logical step for a culture that needs deep time protection and prefers not to haul heavy mass from a gravity well. The carbon dioxide number that felt like a party trick when we used a city full of lungs now reads like a rough capacity plan in a thought experiment. 10 million breathing bodies would match that output if you packed them tight. That is a dramatic picture rather than a claim. Still, it anchors the scale in a way a human mind can hold. The point is not population. The point is throughput. A platform that size could vent 100 kilograms of gas each second without tearing itself apart or running dry right away if it carried deep reserves. The halo we see could be the price of comfort rather than a natural accident. There is a darker twist that fits too cleanly for some tastes. If you wanted to pass through a busy inner system without drawing attention, you would avoid a big dusty tail. You would choose an exhaust that is hard to see in reflected light. Carbon dioxide is less obvious than dust. You would keep the plume broad and even. You would time your path to minimize how often you sit in a clear line of sight for long-range surveys. You might even line up your closest approach to Earth on the far side of the sun to stay masked during the most sensitive moment. Too neat. Too perfect. Maybe. Or maybe a smart navigator forwards planned the crossing with the same care a stealth pilot uses when picking a route over a radar net. We slow down here and remind ourselves where the guardrails stand. This is a thought experiment designed to test whether the observed pieces can click into an engineered picture without forcing the gears. So far the shine, the quiet water, the broad halo, the shy tail, and the workable range of sizes fit together cleanly. That does not mean the picture is correct. A natural shell can mimic many of these features. Reflective frost can grow without any mind behind it. Layered crust can act like armor without a blueprint. A coma can be broad and even if countless tiny sources feed it. We keep both pictures on the wall and we do not confuse the echo of a good story with proof. What tilts the room toward a mini-climax is the feeling that intention sneaks into the edges of the data without an invitation. It is the resilience of the reflective shell idea when we try to poke holes in it. It is the way a managed exhaust hides a tail by design while also keeping heat under control. It is the way a bright skin solves the scary size estimate without asking for miracles from random geology. It is the way small pushes from venting could change a path while keeping a rotation steady. Each of those is a fair natural argument on its own. Altogether they sound like engineering choices. That sound is hard to unhear once you have heard it. Some scientists reply with a firm shake of the head. They say you can always make a natural thing look engineered if you stack enough hindsight. They say the burden of proof sits heavy on anyone whispering design. They are right about the burden. Others answer more gently. They agree the evidence is not there yet, but they also admit that searching for signs of technology on interstellar visitors is now a serious line of inquiry, not a fringe hobby. Those teams will run radio checks, optical checks, and timing checks. They will scan for patterns that nature rarely makes, like regular pulse trains or narrow band reflections or thermal flickers that match a repeating cycle. They will not expect to find a voice. They will listen anyway. This is where the second mini-climax settles in your chest. The idea that Atlas might wear a built skin is no longer a wild shout in the dark. It is a structured guess that lines up with several stubborn facts. That alignment does not hand us truth. It hands us courage to keep the option on the table while we chase harder data. We do not slam the mainstream door. We widen the hallway. We stick a new sign on one of the rooms. Do not enter without humility. Do not enter alone. The next step is to leave this single object for a moment and widen the frame. One case can be a fluke. 2 or 3 can hint at a pattern. We have met a traveler before that refused to stay inside the comet or rock box. It rolled, it glided, it sped up in a way that did not match what our old rules predict. In the next part we open that file again. We pull the pages on the first scout and the second visitor. We ask whether Atlas is a solo act or the latest verse in a quiet song we have been too distracted to hear. Before you move on, hold your own line. If this talk of a built skin feels exciting, remember that excitement can trick us. If it feels threatening, remember that fear can also trick us. The right posture is the same one we used at the locked door. Ear to the wood. Eyes on the hinges. Patience in the breath. Curiosity steady. We will earn whatever answer we get. We step back from the single close-up and hang a wider map on the wall. One strange case tempts the mind to chase ghosts. A line of cases begins to look like a path. Our goal here is simple and honest. We ask whether Atlas is a lone outlier or part of a pattern that has been knocking on our door for years while we were busy with other fires. We pull a few files and place them side by side. We do not force them to match. We let the shapes speak. Start with the first scout our generation met in deep space. Years ago a thin flicker crossed our skies so fast it almost outran our questions. It had a name that meant first messenger. The object rolled in a steady tumble. Its brightness rose and fell with each turn as if it were shaped like a long shard or a flat chip. It skimmed close to the sun, curved, and then drifted away with a small extra push that gravity alone did not explain. No obvious plume. No bright dust. No water roar. The change in speed was gentle but real. The debate that followed tried on many natural coats. Exotic ice that sublimates without leaving a visible trace. Porous foam that vents in a soft breath. A thin sheet pushed by sunlight like a sail. Each picture solved one part and strained another. The file never closed with a clean stamp. The second traveler looked like a sigh of relief in comparison. It carried a classic coma and a tale a child would draw if you asked for a comet. Its spectrum made sense. Its light was dust-heavy. It behaved the way the old book said a sun-warmed snowball should behave. For a season the sky felt normal again. We told ourselves the first scout was a fluke born of a tiny sample size and a rush of excitement. Then a few spins of Earth later the third case arrived with a familiar hint of wrongness. A broad carbon dioxide bubble. A shy water voice. A glow that hugged the skin. A tail that refused to show off. The pattern line on our wall stopped looking like noise and started to look like a wave that rises and falls between normal and not. We can reach deeper into the catalog for context. Comets inside our own system are a messy family. Some carry strong carbon monoxide or carbon dioxide signatures. Some are dust-poor and gas-rich. Some break without warning. Some flare in outbursts driven by buried pockets. Space is generous with edge cases. We even know a few comets with crusts so tough they look like charcoal rocks with a thin scab of ice hidden below. One famous visitor turned out to be darker than asphalt when a close probe touched it. That darkness told us reflectivity can sink to scary lows. Pair that with roughness and you get bodies that swallow light rather than bounce it. If Atlas wears that kind of darkness, the size talk grows. If Atlas wears a frost, the size talk calms. Both have cousins in our files. There is also a thin thread in the literature about dark comets that show little in the way of classic tales yet still nudge their own paths with invisible outgassing. That idea is controversial because invisible is a dangerous word in science. Still, the models exist. They remind us not every push comes with a banner. When we place that thread next to the first scout's gentle acceleration and Atlas's wide bubble, the braid tightens. It could be nothing more than a reminder that gas can hide its footprints in sunlight while still pushing on a core. Or it could be a hint that some bodies manage their breath in ways we did not expect. History outside astronomy helps too. Many fields have faced a run of anomalies that looked wild one by one and obvious in hindsight once someone named the common cause. Plate tectonics stitched drifting continents and mountain belts into a single language. Germ theory took 1,000 scattered folk warnings and wrapped them around a microscope. In each case the pattern hid in plain sight because our mental furniture was bolted to the floor. When someone loosened a leg on the table, the pieces slid together on their own. We are not saying that interstellar visitors demand a revolution of that scale. We are saying that patterns often wait for patience and a willingness to rearrange furniture. If you prefer older echoes, human cultures have carried sky stories about wandering stars and omens for as long as we have drawn on cave walls. Comets meant change in the language of the past. We now understand the physics behind most of those lights, yet the old instinct is still useful. A rare visitor that refuses to behave is a signal to pay attention. Our fear is lower. Our craft is higher. The basic urge remains the same. Look longer. Gather more. Ask better. Let us also widen the frame sideways to technology. In the last decade, the search for signs of craft as opposed to life has grown up. Serious teams now plan to check interstellar passers-by for narrow-band radio chirps, for flickers that repeat with machine-like timing, for radar reflections that look too clean, for glints that match flat plates rather than dusty curves. This is not a vote for design. It is a promise to test for it when the cost is low and the payoff would be immense. The idea would have been laughed out of the room 2 generations ago. Today it sits on meeting agendas with stable funding and calm voices. That shift matters because it turns vague wonder into a checklist. Now we fold these threads back onto Atlas. We have a record of one traveler that broke the simple rules, one that fit them, and one that strains them again. We have a known family of comets inside our system that can be weird in carbon dioxide and crust. We have a few tricky cases without clean tails. We have a research culture newly willing to listen for the hallmarks of craft without flinching. None of this proves that Atlas is anything other than geology and ice under a harsh star. It does show that the ground is prepared for a serious test of bolder hypotheses. If we hear nothing and see only natural physics in finer resolution, we still win. Our maps improve. If we hear something, the room will go quiet in a way few of us have ever felt. There is one more context line that we must sketch even if we keep it faint. The orbits we have drawn for some visitors raise eyebrows not because they are impossible but because they are neat. A path that lines up with the plane where planets circle. A closest approach that happens to duck behind the sun from our point of view. A speed before entry that sits near the average rest frame of local stars. Each of those can happen by chance. Together they form a picture that stirs suspicion in minds tuned to see intent in clean lines. We must be careful here. Human brains love to find purpose in coincidence. We will weigh those paths with math in a later part. For now we mark the feeling and keep walking. This wider frame changes the tone of our story. We are not chasing a single ghost down a dead-end hallway. We are walking through a gallery where more than one painting stares back. The first asks why it sped up without a plume. The second asks why it fit so well we felt bored. The third asks why it breathes carbon dioxide like a gentle giant and refuses to draw a tail. The fourth painting has not been hung yet. It may arrive next year or 10 years from now. Our job is to keep the hooks ready and the walls clear. Here is the honest bottom line as we close this wider view. Patterns can be real. Patterns can also be traps. The only safe way to resolve that tension is to collect better data and to keep competing stories alive longer than our egos would like. Some scientists believe the natural catalog is roomy enough to house all these guests with space to spare. Others are not so sure, and they carry toolkits built to catch faint signs of intention if any exist. Both groups are useful. Both keep the other honest. Both make the final picture stronger when it comes. We end this part with a soft lift in the music rather than a crash. A mini cliff works best when it leaves you leaning forward. The pattern on our wall is not proof. It is a suggestion strong enough to earn more time under the lamp. In the next part we let a bold hypothesis take the microphone for real. We walk through what Atlas could be if it is not only a natural rock and ice body. We build that case from the ground up with the same care we just gave the cautious view. If the bold story cracks under its own weight, we will show the crack. If it holds longer than you expect, we will show that too. Before you click ahead, tell me what the wider frame does to your gut. Does it calm you because it shows cousins for every odd piece? Or does it sharpen your curiosity because the pattern line refuses to lie flat? Your read helps us tune the balance between caution and courage in the chapters to come. We have given patience to the careful view. Now we let the daring view take a full breath. Picture Atlas not as a stray snowball but as a shaped thing. Picture a shell chosen for purpose. Picture a body that moves through starlight in a way that looks natural from a distance yet solves a set of needs on the inside. We do not say this is true. We say this is a clean story to test against the stubborn facts on our table. If the story breaks, we will show the break. If it holds longer than comfort, then curiosity earns another mile. Begin with the skin. A bright shell keeps heat out. Machines we launch use shiny blankets for the same reason. A reflective layer throws sunlight back into space and slows the warming of the interior. If you wanted to keep water locked as ice, a shiny skin would help. If you wanted to avoid a showy dust plume, a sealed skin would help more. You could let a gentler gas like carbon dioxide slip through hairline seams while the rest stays bottled up. The sky would see a wide even bubble and almost no tail. That is the picture we already have for Atlas. The fit is almost too neat and that is why it earns a full test. Now imagine the breath as more than a symptom. Small pushes from gas vents can steer large things if you let them run long enough. Spacecraft already use this trick on a tiny scale. A big body with many balanced vents could dump heat and tune its path at the same time. Open a ring of vents on the sun side when the interior warms and you bleed pressure in a controlled way. Close them as you cool. Use matched pairs so spins stay steady. The external signature would be a symmetric halo that is thicker on the sun side and a rotation that barely changes. That is not proof of intent. It is a reminder that design and nature can look the same if the goal is thermal peace. Ask why someone would choose a rock at all. Stone and ice are the best shields against deep-time radiation. Human engineers have proposed that our first true star ships might be caves inside large asteroids. Drill rooms. Melt tunnels. Line walls with ice. Spin slow for a touch of gravity. Turn the mass we cannot afford to launch into the armor we cannot afford to skip. A culture older than ours would reach for the same physics. A rock is a ready-made fortress. It is also a mask. From far away it looks like a stray. Up close it looks like a worldlet. The line between craft and habitat blurs. The line between ship and small moon erases. We turn to the shine again because size is the quiet weight in every scene. If most of the light comes straight from the skin and if the skin is dark, the body may be huge. That leads to headaches. If the skin is bright by choice, the body can be smaller while the glare stays high. Smaller does not mean small. A large mountain of stone is still beyond any machine we have built. Yet a large mountain is less absurd than a small city if you are picturing a hollowed interior and a slow patient crossing that lasts centuries. A bright shell lowers the mass you must push to hold a set brightness. A sealed shell cuts the dust that would draw a tail. Both are tidy choices if stealth matters. Stealth may sound dramatic. It is simply caution scaled up. If you wanted to sample an inner system without waking every watcher, you would avoid dust. You would prefer exhaust that blends into the common gases of space rather than a forest of reflective grains. You would aim to keep your closest pass behind the glare of the star from the point of view of the system's loudest planet. You would choose approach speeds that look ordinary compared to the local swirl of stars so you blend into the background of motion. Each choice has a natural twin. Together they can sound like navigation rather than chance. We mark that tone without marrying it. There is a question that always rises when this kind of idea enters the room. Where are the seams? Where are the regular flashes? Where is the radio whisper? Where is the repeated pulse in thermal light that screams machine? The honest answer is that we have not looked with the right ear for long. The window where signals could be heard is short. The tools most teams use for comets are not tuned to the quiet rhythms of machines. That is changing. Simple checks can search for narrow spikes in radio as a body drifts by. Simple timing can look for repeating glints that match flat plates turning. Simple radar can sniff for specular reflections off smooth patches rather than the fuzzy echoes that rough rock tends to give. The cost is low. The payoff would be the biggest headline in human history. That does not make the headline likely. It makes the test worth running. What about the carbon dioxide number that keeps sticking to our thoughts? 100 kilograms per second sounds wild until you fold it into the scale of a mountain-sized vault. Then it sounds like routine housekeeping. Venting at that rate would strip a millimeter scale layer over a span of years. A millimeter off a many-kilometer shell is nothing. The interior can stay cold. The exterior can refresh its frost and shade and keep its albedo high. From a distance the look is the same day after day. A calm halo. A shy tail. A bright skin that refuses to dull quickly. Nature can manage this cycle. Maintenance can too. Path choices tighten the theater lighting. An orbit that stays near the plane where planets run is not rare, but it is neat. A timing that puts the closest pass to Earth behind the Sun is not impossible, but it is neat. The speed before entry that sits near a common rest frame for local stars is not unique, but it is neat. Neat lines draw eyes. They can be lies told by chance. They can also be the signature of a careful plan. We will run the odds later. For now we do not sell you the word targeted. We simply keep it in the margin where it can make the cautious side sweat a little. At this point the bold hypothesis stands without shaking. A shaped exterior can explain the shine and the lack of dust. Managed vents can explain the halo, the sun-facing puff, and a steady spin. A hollow rock can explain why someone would choose this design at all. A set of path choices can explain the clean lines that make some hearts race. Not one of these points lands the case. All of them together hold their ground. That is enough to earn the label worthy of test. We keep balance by naming how the bold idea could stumble. If future images reveal a clear growing dust tail that points away from the sun and brightens in step with solar wind changes, that argues for brittle natural crust rather than sealed panels. If the rotation begins to change in lockstep with random outbursts, that nods toward uneven vents rather than matched pairs. If reflectivity drops fast as the object warms and the brightness tracks freshly exposed patches, that hints at frost rather than polished skin. If radio and radar checks come back dull and the light curve never hints at regular flat surfaces, that tilts back to rock and ice. In short, time itself is the fairest judge. A crafted shell would aim for stable behavior. A natural one often flares and sheds and evolves. Here is where the mini-climax hits. You can feel the room lean as the bold idea clicks into the anomalies we have logged. The click is not a verdict. It is an admission that the engineered picture fits the puzzle with fewer patches than some of the natural pictures we tried. That feeling alone does not change science. It does change which measurements we chase with the most hunger while the window is still open. If true, this changes everything we thought we knew about visitors between the stars. If false, we still learn how far natural physics can stretch without help. We close with the right tension for this series. We keep the daring path alive without letting it run ahead. We keep the cautious path working without letting it flatten the thrill. We stand together at a door that may open onto nothing more than a neat rock with weird breath, or onto a view that redraws our place in the story of the sky. In the next part we invite the careful voices back into the room. They will push back hard. They will bring numbers and models and cousins from our comet zoo. They will help us separate the comfort of a tidy tale from the weight of a real answer. Before you move on, speak your plain sense. Does this bold frame feel like a bridge or like a leap? Does it make you lean in or pull back? Your read guides which tests we press for first and how we pace the next steps as the clock on this visitor runs down. We invite the careful voices back to the table and let them speak without interruption. They begin with the principle that nature is allowed to be strange without being artificial. They point out that our sample of interstellar bodies is painfully small. 3 confirmed visitors will not cover the full range that billions of years of chaos can produce. When a case looks new, the safest move is to stretch the natural toolkit before inventing a new kind of actor. That is how science keeps its feet on the ground. The first careful point aims straight at the carbon dioxide bubble. Carbon dioxide does not need as much heat as water to turn from ice into gas. If pockets lie near the surface, a modest warm-up can open them even while deeper water stays stiff. A layered crust makes this easier. Many comets grow rinds as soft ices boil away on each pass near a star and leave hard residue behind. The rind becomes armor with hairline cracks. Gas can seep out everywhere at once without carving big jets. The result looks like a wide, almost round halo with just a little extra thickness on the sun side. That is exactly what we see around Atlas. The second careful point tackles the missing tail and the bright skin. Dust tails happen when small grains break free and get pushed back by sunlight. If the crust is tough or the grains are large, you do not get a bright streamer. If the material is not rocky but fragile carbon dioxide frost, the grains can vanish into gas before a long tail forms. The surface can still shine if fresh frost forms in the cold shade when gas refreezes. A patchy coat of bright ice would lift the reflectivity without turning the body into a perfect mirror. That would let a smaller core look bright. It would also change slowly as patches grow and fade. The fix is not perfect, but it is practical and it uses no exotic ideas. Geometry can also be cruel. A thin tail aligned close to our line of sight can hide inside the glare of the coma. We have been fooled before when plumes looked short from one angle and long from another. As the object moves, the viewing angle may change enough to reveal structure that is not obvious today. The careful camp asks for patience. Snapshots are not the full story. They also push back on the size panic. Brightness is a product of both size and surface reflectivity. If we assume a dark skin because many distant bodies are dark, the size estimate grows scary. If we allow for a brighter skin because frost and fresh fractures are known to gleam, the size drops. The true value probably sits in a middle range that is large but not absurd. A handful of new measurements can tighten that range fast. Until then, arguing from the far ends only feeds fear. The careful camp notes that models built for classic comets may be misreading a coma that is gas-heavy and dust-poor. If the software is tuned to dust-dominated cases, it can overstate how much light comes from the skin and understate how much comes from thin gas and tiny transient grains. They call for reprocessing with models that assume low dust and high carbon dioxide from the start. Calibration matters. Assumptions matter. They ask us not to harden a picture that could soften with a different lens. They bring in cousins from the comet zoo to cut the feeling of uniqueness. We have seen comets with high carbon dioxide to water ratios. We have touched comets as dark as asphalt. We have watched bodies that resist shedding dust until late in their approach. We have seen halos that look round when small sources feed them from all over the surface. Each cousin is a reminder that the family is messy. Put enough rare traits in one body and you can still stay inside the family. Rare times rare is not impossible. It is simply rare. The careful camp then looks at the bold idea and works through its weak spots. If a sealed skin is real, tiny leaks must be tuned on purpose to keep spin steady. A natural crust with many micro-vents can also keep spin steady by simple averaging. If controlled valves were steering, you might expect a repeating flicker as panels or seams rotate into sunlight. That kind of rhythm has not been reported. If a bright engineered skin is present, radar might see cleaner specular echoes than rough rock gives. No such report has landed. If stealth were a goal, a body that large is an odd choice because mass is hard to hide once you start interacting with sunlight and the solar wind. A careful planner could pick a thinner craft and avoid this entire mess. They also address neat path lines. The plane where planets orbit contains most of the mass in the system, so a random path that lies near that plane is not shocking. A closest pass that happens behind the Sun from Earth is unlucky for observers, but someone gets unlucky every year. The sky is big. Events line up. The speed before entry that sits near a local stellar rest frame may look cozy, but that frame covers a wide swath of speeds. Many natural bodies ejected from their birth systems will end up near that average simply because it is the average. Coincidence is common without meaning. Humans are wired to think coincidence equals intent. That bias burns bright when the stakes are high. We should talk about the earlier scout that sped up without a plume. The careful camp is not blind to that case. They answer with mundane ideas that still work if you give them room. Exotic ices can vent invisibly in sunlight and produce small pushes without obvious dust. A very porous body can absorb and release gas in ways that hide the jet. A thin sheet can feel light pressure more than a chunk does. None of these is proven. None is ruled out. The right lesson from that file is humility. One case is not a pattern. Even two cases do not compel a leap. Above all, the careful voices ask for time. As Atlas moves, the sun will bite deeper. Water may wake and show its hand. Bright patches may fade if they are frost and not metal sheen. The coma may change shape as cracks grow and vents open. Rotation may drift in ways that reveal uneven push from natural jets. Each of these would push the story back toward tidy geology. If none of these happen, the room will grow more open to bolder ideas by force of silence. Let the sky decide. Let the data talk longer. They also remind us that extraordinary claims carry an extra tax. Saying built instead of natural does not add $1 of new information to the table on its own. It only adds heat. The way to pay that tax is to propose checks that could fail in a useful way. Radio scans for narrow spikes. Radar sweeps for mirror-like flashes. Light curves watched for repeating glints. Thermal data tracked for cycles that match deliberate control. If those checks come up empty, the bold story loses blood. If any check comes up odd, the bold story earns another day. Either way the work is honest and the field moves forward. By the end of their case the temperature in the room is lower. The careful view does not kill the bold one. It does force it to earn every inch. It shows that many of the observed features can grow from simple rules stacked in fresh ways. It shows that our instruments and models can bias us toward the story we expect to see. It shows that coincidence can wear a mask that looks like a plan. None of that makes the thrill vanish. It makes the thrill answer a list. We close this round with a fair cliff. Even this careful frame does not explain everything to full satisfaction. The ratio between gases is still the loud part of the spectrum. The lack of a bold tail in the face of a bright object still bothers many of us. The size range still forces us to accept either a very large body or a very shiny skin. The path lines still feel neat whether or not math can excuse them. So the question that brought us here remains. Are we looking at a rare natural wonder or a mask with a purpose? Tell me where your head is after hearing both sides. Which fix felt strong and which felt like a patch? Your notes help decide which tests we press for as the window narrows. We have saved the heaviest card for now because it does what great twists always do. It takes the scattered odd details and folds them into a single image you cannot unsee. Chemistry was the first jolt. Shine and tail were the second. The third anomaly is the path itself. When you trace the reported track of Atlas across the map of our system, it looks less like a wild stone thrown by chance and more like a careful thread pulled through a cloth. The line stays close to the flat plane where our planets travel. It swings near several worlds in a tidy sequence. And when it comes closest to Earth by distance it hides behind the Sun from our point of view. Each piece on its own is neat. Together they feel deliberate enough to make the careful mind sit up. Begin with the flatness. Most random interstellar bodies can arrive from any angle. The sky is a sphere. The ecliptic is a thin dish inside that sphere where our planets run their laps. Plenty of natural visitors cross that dish by luck. But when a track hugs the ecliptic instead of slicing through at a steep angle, it means the object moves in the same thin layer where gravity and traffic are thickest. Ships in an ocean keep to shipping lanes for good reasons. Debris does not. A lane is not proof, yet the image is hard to ignore. A rock could drift that way by chance. A navigator would choose it for practical reasons. The lane brings you near targets with minimal effort and simple math. Now talk about the swing past multiple planets. A random flyby is just that, one quick nod to a world and then back to the dark. The reported path for Atlas brushes past more than one planet at modest distances during its run toward and away from the Sun. That is useful if you want to sample environments or compare magnetic fields or taste different solar wind conditions without changing course much. Natural bodies can graze more than one world by accident. It happens. Yet a sequence that threads 3 clean opportunities with a single path reads like a tour in a planner's notebook. We do not shout intent here. We note that a simple straight road happens to pass all the right roadside stands. The third piece is the one that makes your neck prickle. At the moment when Atlas is nearest to Earth by distance, the line of sight from our eyes runs straight through the Sun. That means the brightest lamp in the sky sits between us and the object at the very moment when curiosity peaks. Your instinct wants to shout that this is too neat. The careful voice answers that someone always ends up behind the Sun and that bad timing is a constant joke in astronomy. Both can be true. The neatness remains. We are not pointing at a single coincidence. We are pointing at a trio of neat lines that all lean in the same direction. There is an echo here from our first scout. That earlier visitor reached our system moving at a speed that matched the local average of star motions rather well. In plain words, it drifted in with the background rather than sprinting or lagging. That made it easier to meet and study if anyone had planned ahead. Atlas does not need to share that trait to stir the same thought. When more than one file paints a picture of lines that help observers rather than hinder them, the human brain begins to whisper that somebody might be drawing those lines on purpose. We accept that the whisper can mislead. We also accept that ignoring the whisper is a poor strategy if we want to catch a real pattern early. The path also matters because geometry can hide behavior. A tail can be hard to see if it aims away from us. A thin jet can blur into the haze if it sits in the sun's glare. A builder who wants to keep dust off the record would time the geometry to make every snapshot a little less clear. A rock would not care. If the absence of a loud tail is already on our list, a route that keeps the brightest light in all the wrong places starts to feel like a supporting actor in the same scene. It is not a confession. It is a hand on the dimmer switch. Let us imagine the navigation problem from a cold seat at a plotting table. You want to fly through a new system in one pass. You want to map space weather near more than one world. You want to keep your thermal budget under control. You also prefer not to draw a big arrow with a dust tail that says "look here." You choose a plane near the ecliptic to minimize the energy you waste diving up and down. You pick a speed that blends with local traffic. You use carbon dioxide vents near the sun for cooling and tiny course trims. You plan your closest approach to the noisy blue planet on the far side of the main lamp so you are hardest to see with simple telescopes. You leave the system with the same quiet you brought in. Every step in that chain has a natural twin. Together they rhyme with intention. The conservative side pushes back here and we hear them out. The ecliptic is where most mass sits, so a random path landing there is not shocking. Multi-planet grazes happen by chance for some trajectories that come in at the right angles and speeds. A sun-masked closest approach is bad luck for us but not rare in a large calendar. All true. Yet the third anomaly is not a single number we can wash away with a better model. It is a motif. It is the sense that somebody threaded the needle 3 times in a row with the same thread. We cannot throw math at that feeling without real distributions to work from. Our sample is too small. The honest move is to keep the feeling and the math both alive and let future arrivals settle the argument. There is a technical sidebar worth naming in plain language. If a body planned this route, it may have used tiny sustained pushes long before it reached our neighborhood. A slow burn far out can shape a path more gently than a hard shove near the target. The signature near us would be nearly invisible. That is how a cautious pilot works. That is also how nature works when weak forces act over long distances. Again the echo appears. Again we either hear a plan or we hear patience. Both are possible. Only more data will tell which tune we are actually hearing. The moment of flip arrives when you stack all three anomalies in one picture. A giant yet gentle carbon dioxide bubble with water shy. A skin that shines while dust refuses to paint a bold tail. A route that slides through busy lanes and dodges the direct stare at the critical moment. If you wanted to design a visit that hides the usual comet clues, protects the interior from heat, and minimizes our easy looks, you would end up with something like this. That sentence should make you excited and uneasy at the same time. It should also make you cautious because the human brain loves stories that fit too well. We name the fit. We do not marry it. This is the moment everything flips because the path forces humility on both camps. The cautious camp must admit that tidy geometry can sharpen the sting of the other anomalies. The bold camp must admit that neat lines are a trickster that turns up in random data more often than our guts believe. The only safe move is to propose tests that the sky itself can pass or fail. That means timing future looks when the angle changes. That means logging light curves long enough to catch any repeating glints. That means scanning in radio bands known for machine use without fixating on a specific handshake. That means watching the spin for any sign of control as the sun angle shifts. If the path is just pretty chance, these checks will bleed the thrill away. If the path is a plan, the tests give it fewer places to hide. We end this section standing on a ridge. Behind us lie the first two anomalies and the arguments that tried to tame them. Ahead stands the high ground of the climax where we ask what it would mean for us if the boulder reading turned out to be right. The air is thin on that ridge. The view is wide. Take a breath and look down at your own hands. Do they shake with the idea that we might be sharing a sky with careful distant minds? Or do they steady with the belief that nature is enough? Both reactions are human. Both keep us honest as we walk into the next act together. This is where we let the idea run at full speed and watch the horizon tilt. If the bold reading is true, then Atlas is not only a rock with quirks. It is a crafted body moving with intent. It wears a bright skin to keep heat out. It breathes carbon dioxide in a calm way to manage both temperature and tiny coarse trims. It hides its dust so it does not draw a giant arrow across the sky. It slides along the busy lane of the ecliptic and times its closest brush with Earth to pass in the glare. If this picture holds, then we are not alone in a quiet scientific sense. We are sharing a sky with minds that plan ahead. Imagine the first clean confirmation. It would not be a dramatic hello across the void. It would be a small thing that breaks all reasonable doubt. A repeating glint that ticks like a metronome as flat facets rotate. A narrow radio tone that switches on and off in exact steps that match no natural plasma song. A radar echo that comes back too sharp for rough rock and repeats with the spin like a mirror flash on a lake at sunset. One such sign would turn our careful maybe into a measured yes. The world would not end. The world would change in a way that feels like waking up in a brighter room. Science would pivot hard and fast. Telescopes that fight for time would clear schedules. A flood of proposals would chase every wavelength and every angle. Teams would design quick software updates to hunt for patterns we once called noise. Young researchers would find their careers born in a single week. Old hands would feel the shock of being wrong in the best possible way. The quiet work of the past would pay off in a single clean plot shared in a press room that used to cover rocket launches and now covers a far bigger story. If true, it changes everything we thought we knew about visitors between the stars. It also changes how we fund questions. Budgets that starved for decades would suddenly look like bargains. The first debates would be practical. Do we try to speak? Do we only listen? Do we tag along with radar pings or do we stay dark and observe? The safe move would be to watch without shouting. The ethical move might be to ask before probing. We would discover that we already argued about this for years and never took the fight seriously because it felt like science fiction. Now the votes would count. Space agencies would hold emergency roundtables. Military advisors would sit near astronomers for the first time without owning the room. The pressure would be to keep calm and keep the data flowing while the object is still near enough to hear. Philosophy would jump the rails into daily news. Ancient questions would land in morning talk shows. What does intelligence mean when it grows under a different star? What do we owe to minds we cannot see? What does progress look like if someone else arrived here long before our first telescope blinked open? These are not soft questions. They drive how we teach children, how we design laws, how we treat the unknown. Some people would feel wonder. Some would feel dread. Most would feel both and then find a steady middle after a few nights of restless sleep. Religion would not break. Traditions have a way of absorbing new light and finding room for it. Some leaders would see the find as proof that creation is wide and generous. Others would take a long breath and ask how their stories sit with the new facts. The honest ones would say what honest scientists say. We do not have all the answers. We do have a duty to seek them without fear. In homes and dorms and late-night diners people would speak softly about meaning. That is healthy. It is also overdue. The economy would not explode and it would not freeze. The shift would be deeper than a stock chart. Young people would pick majors with new fire. Materials science and plasma physics and low-noise radio engineering would look chic. Private space would feel both humbled and charged. Building bigger telescopes would feel like laying roads rather than building monuments. Insurance underwriters would quietly update models for space risk without saying why. The sober truth is that an engineered visitor does not threaten us by existing. The threat comes from ignorance. The cure is better light. Policy would stretch. We would need rules for how to share raw data quickly across borders without letting rumor eat the signal. We would need calm chains of command that keep the microphones in the hands of those who can explain a spectrum without turning it into a slogan. We would need to decide how open to be about new listening posts and how to avoid trampling civil radio bans while we hunt for whispers. In a better world these choices would be made with the same patience we use to build a bridge. In our world they would be made fast. The best guard against bad choices is clear public understanding in simple language. That is why we tell this story the way we do. Now picture the interior of such a body if the shell is real. It would not look like a spaceship from a movie. It would look like a carved cavern with beams of stone left in place to carry loads. Tanks would hold gas near the skin where it can bleed heat and shape the coma. Pits would store ice as both shield and resource. Long corridors would run like veins. Lights would be rare and warm. Machines would hum in cycles too slow for a human ear to notice. It would feel less like a machine and more like a monastery built for a single purpose. Crossing deep space is not a chase scene. It is a patient craft practiced over centuries. If such a craft exists, then other one-off signs may already sit in our archives. Old surveys might hide narrow spikes that nobody flagged because they seemed like interference. Light curves might hold faint ticks that look like a bad pixel until you know what rhythm to expect. Students could find world-changing signals while cleaning old plots with fresh code. Entire careers would bloom from the patience of people who kept the messy folders when everyone else cleaned their drives. The future always rewards archiving and humility. There is also the long view to hold in your hands for a moment. First craft leads to second craft leads to a network of visits over centuries. If interstellar travel is possible for them, it is possible for someone else. That means the galaxy is not empty of roads. It is thick with paths we cannot yet see. That is not a threat. That is a context shift. It makes our own ambitions feel less like a fantasy and more like a duty. You do not stay in one valley forever once you know there are passes through the mountains. This climax is not a victory march for the bold camp, and it is not a defeat for the careful camp. It is the honest naming of what hangs on the answer. If Atlas is a natural wonder, we still win because we rewrite parts of comet physics with better data. If Atlas is a crafted body, we win because we learn that minds can reach across the dark. In both futures the right move is the same. Keep listening. Keep checking. Keep every claim on a leash until the evidence pulls hard enough to break it free. We end this peak standing at the edge of a decision we cannot rush. The window to test these ideas is open now, not next decade. The object moves. The angles change. The chance to hear a clear tick or see a clean glint may come only once. The good news is that the tools exist and the costs are small. We can point dishes and eyes and patience at the right times. We can share raw streams without ego. We can let the sky speak for itself. If we do that, and if the Boulder story is true, then the first unambiguous sign may arrive in a graph that looks simple enough to fit on a coffee mug. A thin line. A steady beat. A room gone silent as the world turns a page. Before we step down from this height, tell me in plain words how this lands with you. Does the idea of a crafted visitor fill you with hope or concern, or both? Would you vote to send a hello or to stay quiet and watch? Your voice matters even here, because how we handle a discovery like this should not belong only to experts. It belongs to everyone who looks up and feels their chest lift a little under the same sky. We bring the arc down to a steady glow without turning out the light. The truth is still on the other side of the door. Atlas keeps moving. Angles keep changing. Instruments keep waking at odd hours to catch a cleaner look. The puzzle did not end with a dramatic reveal. It widened into a watch. That is not a letdown. That is how real discovery feels in the middle. You hold a handful of solid pieces in a larger shape you can sense but not show. You press the edges together each night and you test the fit again in the morning. Some days the picture sharpens. Some days it slips. Curiosity survives both moods. Here is what happens next if we keep our promise to listen hard. Telescopes that split light in the infrared will take more spectra as Atlas changes its distance from the sun. If water wakes deeper in the skin, those fingerprints will rise and fall in a way that tells us how heat is moving inside. If the carbon dioxide breath stays loud while water stays shy, that strengthens the case for an unusual surface or an unusual plan. Wide field surveys will keep watching for any faint tail that might appear once geometry shifts. If a streamer finally shows, dust models get their turn at bat. If no streamer appears, the argument for a sealed or tough skin grows teeth. Eyes that prefer flicker over color will keep tracing the light curve for rhythm. A natural frost patchwork should drift in brightness in a way that maps to rotation and to small outbursts. A crafted skin might show repeating glints that stay stubbornly regular across many turns. That kind of tick is easy to miss when you're not looking for it and hard to ignore once you see it. The right way to catch it is boring and honest. Point a stable eye. Record for many hours. Let code scrub the pattern out of the noise without forcing it. The absence of a tick does not prove nature. The presence of a clean tick would tilt the floor under our feet. Radio dishes will take their quiet turns as well. A simple scan through narrow bands can rule out some kinds of emissions that machines tend to make. Nobody expects a hello. A low probability search is still worth running when the cost is low and the prize would be history. A few teams will try radar when the angles allow. Rock scatters radar in a messy way. Smooth plates throw back sharp flashes. A single bright glint that repeats with the spin would not end the story, but it would change the tone. Each check is a clean pass or fail that adds weight without drama. That is how you keep your footing on a slope like this. There is also work to do in the past. Archives are full of spectra and light curves that never got a second look. Students and patient coders can hunt those piles for narrow spikes or faint rhythms that make more sense now that we know which questions to ask. A future headline may come from an old plot that sat in a folder because nobody had time to chase a weird line near the margin. The sky rewards people who keep their messy notes. The story favors minds that can say we missed this and now we see it. All of this lives under a simple banner that our team and your attention can share. Let the sky decide. Let data drive wonder rather than the other way around. Some scientists believe the catalog of natural outcomes is roomy enough to hold everything we see in Atlas with comfort. Others are not so sure and they want to give the bold idea a fair shot without making it a campfire tale. Both instincts keep the hunt clean. Both remind us to hold our metaphors lightly and our measurements tightly. While the work continues, we do not have to sit in silence. We can practice the habits that make us ready for whatever answer comes. Speak plainly. Avoid the soft fog of jargon when a short sentence will do. Draw diagrams that a 10-year-old could sketch after watching for 5 minutes. Share raw looks when you can without fear that someone will laugh at a noisy plot. The first person to spot a repeating glint may be a hobbyist with a patient camera. The first person to catch a narrow radio spike may be a ham operator who knows how to keep a clean log. Mystery belongs to everyone who shows up with honest tools. Hold 2 futures in your hands and notice that both are good. If Atlas turns out to be a rare natural wonder, we get a new page in the book of how cold bodies behave when a warm star prods them. We stop teaching one rule like it applies everywhere and we start teaching a richer set of paths. If Atlas turns out to be a crafted body, we get the most human gift of all. Company in the dark. Not a threat. Not a savior. Just the proof that minds can cross the ocean between suns. Either outcome pushes us to be better listeners and tougher thinkers. Either outcome makes next year worth staying awake for. Do not mistake an open ending for a weak ending. The strongest stories in science end with doors still ajar and footsteps still heard in the hall. That open space is what keeps the best people at the bench and at the eyepiece. It is what brings new people to the field. It is what keeps the rest of us feeling young when we look up from a parking lot and catch a moving point that does not care what kind of day we had. We stand together at that door now. The metal is cool. The hinges are quiet. The seam leaks a thin breath we cannot name with certainty. The next sound might be wind. It might be a machine. It might be the long slow sigh of rock and ice under a sun that is warm and close. You do not have to choose tonight. You only have to hold the question with care. So we close this chapter with a cliff rather than a period. The facts we have gathered point in 2 directions at once. A wide carbon dioxide halo that dwarfs the usual water voice. A glow that clings to the skin while dust keeps its head down. A path that slides along a busy lane and slips behind the main light at the exact moment our curiosity peaks. If true, the bold reading changes everything we thought we knew about visitors between the stars. If false, the careful reading still changes what we teach and how we search. Either way, the next frames matter. Either way, this is the edge of a page in a book that people will read long after we are gone. Stay with us as we push through the next windows. Add your voice in clear words about which tests you want to see run first. Keep your eyes open for updates as angles shift and instruments breathe. If this story turns a corner in the coming months, you will want to be here the moment the line on a screen steadies into a beat that nobody can shrug off. Subscribe so you will not miss the moment history changes. Until the next signal, keep your ear to the door and your mind in the light.